Hello, Spark fans, and welcome back to Advancing Spark, where this week we're looking at the new Databricks 7.5 release. So it's still in beta, and there'll still be some new features and other things thrown into it, but I thought we'd take a quick look at the flagship features that are going in there, and let's see how they work. So, what have we got? Okay, so we're on the Databricks Runtime 7.5 beta. We've got a few things in there. First and foremost, we've got this asynchronous checkpointing. So with the latest Delta, every 10 or so times that you make a transaction, it's going to, rather than just create an extra JSON transaction log, it's going to wrap the previous ones up into a Parquet file. Now that means that any future reading of the table is nice and quick because it doesn't have to go and read thousands and thousands of Delta logs. It can just kind of read the latest Parquet plus any checkpoint ones that come in since. So that's great. However, if you're doing any streaming and you're constantly streaming into a Delta table, and then every 10 it's having to do that checkpointing, they're like occasionally you had duration spikes. That one micro batch just take a lot longer than the others because it's also doing the checkpoint compaction at the same time. So it sounds like they made that asynchronous, so they've taken that out of the critical path of getting the micro batch in. So suddenly, your Spark streaming jobs, if you're going into a Delta table, should be a lot smoother. You should see if you've got fewer spikes in terms of stream duration. So that's only going to be good, right? So that's one nice little feature. Again, depends how much of that kind of high latency real-time streaming that you're doing. Next one is super important. So there's always been this slight disconnect between Hive having its own metadata structure and its own representation of what's stored within the table, and then the Delta table having its own schema, its own representation of what it contains. And because we've got things like schema drift, because we've got the ability to overwrite Delta tables and force schema overwrites and do various things like that, it doesn't automatically update Hive. And so occasionally you'd have a Hive table that doesn't actually understand what the Delta table now looks like. They can get out of sync. And so you're constantly doing like refreshes, constantly running jobs to resync that Hive metadata. So this change is all about doing that automatically. So essentially, kind of anytime that you try and use Hive over a Delta table, it'll be doing a quick sync, make sure it's got the latest schema, update that in the Hive metastore. So next time someone explores it, next time someone looks at the structure, next time someone trawls data out of Hive, they get the most up-to-date view of that Delta table. Now, with all things like SQL Analytics and more people pointing BI tools such as Power BI at the Hive tables, and that's just going to bring the metadata back directly rather than go to the underlying Delta tables, it's really important to get that metastore up to date. So that just means that we don't worry about it, essentially. We can kind of just chill out and be happy that if we're making any changes, we're using things like auto merge, if we're pushing lots of fast changing data into Delta tables, then Hive should stay up to date, which is super useful. And again, we've also got kind of a few different things. So based on the commit date, based on the update version, we'll be able to get some kind of sync information. So it's pretty good. I've yet to test it out, so that'll be interesting to see how quickly it updates. How is it every so often it updates? Is it force update? Does Describe suddenly get slower because it's now actually doing a quick check and getting them in sync every time I do it? We'll have a look. Okay, so this is an important one. So merge into, super useful. It's the main way of saying, I want to do some kind of, I want to do a merge. I want to take some kind of, I used to call it a delta, some kind of change data coming in. I want to apply that to a table, updating any rows, deleting any rows, inserting rows that didn't exist before, all that kind of good CDC style updates. Now, if we're using Schema Merge, that makes it super powerful. It means if actually the data I'm receiving, my change data has changed, then actually I can apply that without thinking. I can say, hey, it's got an extra column. Don't worry, just put it in, which is the fundamental tenet of lakes, right? I don't want to have massive data management headaches. So if data's coming in and I can merge that into my tables, fantastic. Now, it used to be the case if I had a struct in there, if I had, like sort of a nested dictionary or kind of list of attributes, if that changed, then merge into was like, I can't do that. So you had to be very, very strict in terms of how you're going to do your struct types. Your structs can't change, but your other columns can to a point. And essentially merge into like sort of the auto merge has always had just this list of restrictions. It could do, like, at first it was super simple. As long as it's just a column being appended, it can handle it. It's kind of like a column being appended or data types getting bigger, kind of we're increasing from an int to a big int. That's kind of okay. And slowly, we're getting more and more functionality added into the Delta tables to enable this kind of stuff. So this one, saying we can now support nested columns, is fairly big because that's actually a huge change, saying slap bang in the middle of my table, I've got a struct. I want to change the structure of that as I merge into it. And it'll just go, all right, cool. So let's have a look at that one. So I've got an old runtime. It's got runtime 7.4. It's the current live one. And I'm just kind of creating a quick data frame. So I've got this data frame. It's got a load of, I think, Pulp Fiction characters. And in the middle of that, we've got this struct. So we have a look at what our data frame looks like. We can see flat employee ID, an object called employee, and then I've got a name and a surname inside it. So again, I've got a bundle of attributes coming in as one nested column, and then I've got some more straight flat columns. And if we take a look at that, you see this kind of thing, So you see we've got kind of an attribute baked in the middle of it. And that's the same kind of thing if we're getting data in and we did a split, we'd see that a lot. If we're getting nested JSON, you see this kind of stuff all over the place. Okay, so we're going to write that down to a new Delta table. So there's an empty folder currently. So I'm writing it out as Delta, mode override, going to save it. And then I'm going to make some change data. So I've got essentially the row as it was. And we want to say, actually, I'm going to add a nickname in the middle. So I'm adding a new attribute called nickname. I could have called him the boxer. And that's just updated. So I'm just jamming a new attribute into the center of that struct. And they've got other bits. So I think salary has changed. So he was on 20K, he's now on 25. That's fine. And I can save that as basically as a new table. And we can do that. Okay, so I've got my change data. My change data, just a single row. It joins to an existing ID. I've got this change inside my nested struct. I'm going to set auto merge as true. It's fine. I want to be able to, because I'm using the Python style merge syntax, I could have, when I created that table, set the merge option. So that's kind of like a blanket. Always allow me to merge whatever I'm doing. I could do that on a table type by table basis. And then I'm going to try and merge it in. So take my change data, put it in. It's like, no, okay. I've got my fairly strict struct here, which is my name and surname. I can't cast that name, nickname, surname into that. So that's what currently happens. That is your 7.4 existing functionality. So what we're saying is in good old 7.5, which is our new beta release, that shouldn't be the case. So let's follow that through again. So we've got our existing table, got our existing bit of data. So we're still on 20K, which got the name and surname. We're saving that down as we did before. And there we go. So the same difference. We've got the nickname in here. We're adding it in. We're updating that. So we can go and get that updated data set. So that brings us to like the same point, right? So we can do get auto merge turned on, and then we're ready to run that exact same merge statement. So that code, when we're doing that merge, is exactly the same. So we're not having to turn any other options on. It's a config that we can switch on and off if we need to. But I can now just do a merge and say, take my change data, jam it into my original table, merging the schema, so updating the attributes, including new attributes if you find them, and just deal with it. And that's kind of where we want to be. So it's going off, it's running that Spark job now, it's updating the Delta log so that it actually knows it's got that updated schema, and hopefully also telling Hive. And that worked. So now if we have a look at it, go and see what's in that table. And then we see, there we go. So our top employee, we've now got that additional surname attribute. And so nickname. And so it has gone through and edited everything. So everything else, it's now said, actually, so these still have that attribute. So it's not kind of like a true nested ragged. These attributes are completely optional. It's not like if you queried loaded nested JSON and some objects would have that attribute, other objects wouldn't, and no one cares. It is still enforcing a fairly strict schema inside that struct, but it's allowing for the overall growth of that and the overall changes to that. So interesting. It's actually allowing that level of flexibility. Now I want to have a bit of a more of a play with that and just see what we can do in terms of, you know what, I'm getting 10 columns that I always expect. And then there's another optional between, 1 and 20 columns that I may get in my updates. And I don't really care if I get them, if I don't get them, but I want to collapse all of those into a struct. So I've got my fixed schema, my known schema, and then my optional extension schemas. And if I can just throw that into a merge and it'll just handle it. It won't care if it's missing, it won't care if it's added in, and it'll just slowly make sure I'm not throwing away the data, but be able to handle that main chunk of unchanging data with the extras. That'd be amazing. That'd be fantastic for saying, I've got a very flexible lake and I can handle what's thrown at me. So I don't know if it can fully do that. I don't know if it's going to complain if I give it some other data. In fact, let's try it. Why not? Let's do it again. Let's say I'm going to take one of my other data sets. So I just push in the same person. So let's push in a row. So we're going to get an existing one. I'm going to say, I don't know. Let's change the HR. Now over in marketing, and that's gone up to 35. Okay, so just top header level stuff doesn't have a nickname. So this is one, so we're kind of modeling one record came in, it had some extra info. Next record comes in, doesn't have it. Do we care? So I'm going to change that folder so it makes a clean Delta table. We're not doing an overwrite or anything. And then we can go and push that through. So making a clean table, single row, I'm going to merge that in again. And I'm just curious to see, is it going to complain that it doesn't have that nickname column now? And that'll change about how useful and flexible it is. So that liked it. That's okay. Didn't have a problem. Oh yeah, okay. That's not too bad. So even though this is still using the original structure, even though this is still using the structure I first had and I don't have the nickname in there, so it's updated the schema. It's changed it so it's now expecting to always see that updated, to expect that nickname attribute, but it's not errored. It's not told me, no, you've not provided that new attribute that we're now expecting. So that's allowing for like almost a ratcheting effect, it's allowing them to grow the schema, but not enforce the extra bits. And that becomes super, super useful. So if each time I get a slightly different flex, and actually here we go, I don't know, let's go for title. Miss, fine, or Ms. Okay, and do that into a different place. So again, another update on the same one, adding in a different attribute, but not including that first nickname attribute. So how flexible is this going to be in terms of pushing that in? And hopefully we'll see the nicknames null. We've got that new one, so we've got that title. Mez didn't have a nickname. The other one where we had a nickname, we don't have a title. It just accepts it. So that for me is a really nice way of collecting change into fixed to known locations in my table. And then everything else is the more controlled, the more managed. Essentially, we can have tables that are a combination of managed and unmanaged schema. Cool, right. So other parts of Databricks 7.5 merge into now uses optimized writes. And that's useful. So essentially kind of optimized writes, when you're writing out, by default, if you don't have optimized writes on, it'll basically write out however the data happens to be distributed inside your Spark cluster. So if you've got like 128 kind of RDDs, your one data set broken up into 128 different blocks, that's how many files it will write out. If you then do partitioning in that, it might break them up even smaller. If you have any kind of wide transformations, that might make it break up even smaller. And then by the time you write out your data, it could be writing out absolute teeny tiny Parquet files inside that Delta table. And that's not efficient. So you've got two levels of optimization, auto-optimize, super useful. That means when it's writing out, it does two things. It optimized writes, looks at it and says, okay, I'm going to result in like a load of tiny, like 1 meg or a few K Parquet files, collect them together, organize my Spark job so that it collects and collates, basically coalesces those partitions into chunkier ones. So we're aiming for 128 meg Parquet files once it's written out. So we'll just kind of collect the data and just try and get that as an optimal thing. And it'll interrupt your writes to make it get as close to that as possible. Now, when you run the full optimize command as a separate maintenance job, that aims for a gig. So that's still going to see those separate 128 meg files and trying to smush them together. But that is super useful for just making sure that when you're doing merge into, you're right. Okay, now optimize. Okay, final one is to enable what we're doing with that kind of schema evolution. The kind of change it so it's now resolving nested columns by name. So you can actually sort of, basically, it'll understand what's going on inside that struct and it's not going to force it to be ordinal. And that's kind of one of the problems with the way we're doing things over here. And we're saying, we're now expecting inside that struct, we've got 1, 2, 3, or 0, 1, 2, in terms of the name, title, surname. It used to resolve that in an ordinal way. So we tried to do an update. It would just override, in this case, name, surname, nickname. So it would go name, title, surname, and just override those and be fairly dumb about how it updated things inside a struct. Now it does by name. So if something happens to give you attributes in a different order, it'll go, and it'll just attach it to the right attribute inside that struct. Again, bakes into that same story of making struct auto merge, auto updates so much more useful. Okay, finally, other bits. We got clones now GA. So if you've seen the Delta clone and the ability to do shallow or deep clones of your Delta tables, that is now generally available. It was previously in preview. And you can now do some table properties. So if you wanted to create a clone, but you didn't want to actually sort of pull over all of the same things, and you wanted to do set auto merge, if you want to do various different options in there, that's now possible. So that is super, super useful. We've got the example of what we've got on there. I don't think we do in kind of terms of that straight away. Okay, well, so the same way you can set, anytime you're creating a table, especially a Delta table, and you can set properties on there, you've now got the ability to override those. So you could have, you know what? I'm not sure I want to set that table property, like Delta table. Tell you what, I'll make a clone of it. I'll set that property. I'll then do my update, test it. If it works, I'll delete my clone. That kind of checking things in prod, super useful. That's what clone is amazing for. So the ability to include table properties in there is great. Okay, so looking at the kind of Delta implicits. So essentially kind of that's bringing this in. So previously when we're looking at doing spark.read, if we're trying to do Delta table, we'd need to do .format Delta, .load, and then give it a path. And it never really felt like a first class citizen, first party format. So when you can do spark.read.csv, it's like, there's a CSV reader built in. That's essentially all it's doing. So now available in Scala, not in PySpark yet, you've got the ability to say, I just want to load from a Delta. Now, I never use that. I try to avoid using that because I like to pass the format in as a parameter so I can fully parameterize all my Spark scripts. And you can't do it if you're using the implicit. You can only do it if you're using .format and then passing the parameter of what formatted stream is. But there'll be some times when that's useful. And certainly if you're just trying to do a quick, what's in that Delta table? Just doing spark.read.delta will save you a bit of time. It's all good. The SQS connector, I've got to say, I don't know too much about. I think that is an AWS thing. I am fully on Microsoft land in Azure. So I believe there's some better things with that connector to make it, well, I guess, fetch records in parallel. That kind of makes sense, but I don't know too much about it. Again, Redshift, don't know too much about the assume role thing. That one is a complaint that we've seen in kind of a few different cases. So essentially, if you're just looking at some data, it's going to auto format the SQL decimal. So occasionally, it'll look like you've got rounding errors if you're looking at data through your notebook. And actually, you haven't. But again, it's just a formatting thing. So now it's going to display it better in notebooks. And that should be a little bit nicer, especially people doing financial reporting and that kind of thing inside a notebook, which is a great use case. And we're trying to get users on board to be using that kind of lake house approach. You can do your analysis inside Databricks. And so you don't want it to format and force loss of precision in data types. So you weren't losing data, but it wasn't displaying the data the way it should be. And now that's been fixed. Okay. And then there's a normal giant pile of here's all the actual Spark bugs. Here's all the issues raised. Here's all the libraries that have been updated. I'm not going to go through that. So that is our brand spanking new Databricks runtime that we're going to see hopefully going into GA at some point in the next month or so. And yeah, I guess for me, there's just the one big story, right? So there's lots of little nice things. It's kind of the Hive sync is good. Making sure streaming just doesn't occasionally have spikes, great. But that struct auto merge story, the ability to go, I don't care if my data's changing. I don't want to actually change my whole table, just bung it into a struct. Actually has huge amounts of potential for the kind of work that we're doing in terms of building lakes that are flexible. Because that's the danger of the full Delta story. Delta is great for having structure, for putting governance and rigor into a lake. But if all of your data in the lake is using Delta, you're then essentially over-enforcing structure. You lose some of the agility of the just throw it in the lake, worry about the structure later. Whereas things like this, the more we can say, I still want all the benefits of Delta, but I want the flexibility of not having a schema defined. And this is kind of giving us that middle ground, giving us the ability to make Delta tables rigorous, governed, well managed, but also super, super flexible. So all good stuff. We'll be digging into the meat of it and testing out and doing some ETL scenarios with that kind of auto merge turned on. But otherwise, hope you're having a fantastic December and we'll catch you again. Cheers.